Hello and welcome to the very first video of this series. We're going to be moving into online teaching. I hope you are able to follow everything I say and also have the chance to ask me questions. We're going to have multiple sessions where we could actually meet online through the Zoom and we'll be able to answer your question. At this moment, I wanted to indicate that I wanted to go over some of the material we covered in Chapter 4 and continue with Chapter 5. I'm not going to be covering every little details in either of the chapters because you have the homework that you have done and uploaded. And also, if you needed anything to be clarified, of course, you know how to reach me through email, phone, texting, or actually regular voicemail. We shouldn't really be at any condition that should prevent us from communicating with each other. Anyway, I wanted to go ahead and talk about the logical operator that we ended up our discussion in the class and start from there to continue following up on closing chapter 4 and continue to talk about chapter 5. So at this moment, I wanted to remind you that we had discussed 4 types of logical operators. These were AND, OR, and XOR, and NOT. And as we all know, it's a limiting logical operator because one elements must be existing in both sets in order for it to be part of the intersection or result into what we call the result of the NAND operators. So in this case, if I take an example for a set, let's say 1, 2, 3, 5, and I have another set B, which is going to be, let's say here, 2, 3, 6, 7, and 8. So for us to look at the intersection between those two sets, when I say A and B, it's going to be basically what they both have in common. So it's going to be the 2, the 3, and that's it. That's actually what they both have in common. So in order to refresh your memory about the truth table that you came up with, I'm going to go ahead and insert the table with 5 columns and 4 rows. Okay. And the very first thing I wanted to go ahead and type true and true and true. That's going to result into basically true, and that's the only condition that is going to be true. Both conditions are true, it's going to result into true because that is the nature of AND, that both conditions must be true. If I hire 2 people to attend a conference and to run the conference, list both of them have shown up in the conference will not be held. So we need to make sure that both of them are there. But if one of them showed up, that's not enough. Therefore, if the first one showed up and the second one didn't show up, then obviously it's not gonna really lead to what we expected. Therefore, it's going to be false. The same thing if I do end up with the first one didn't show up, false, and the second one did show up, and therefore it's not going to be enough because I need both of them to be true. So therefore, the result is false. I'm trying to slow down here, hopefully. And if the first one didn't show up and the second one didn't show up, obviously both of them are going to be absent. There's no way you could really hold the conference. Therefore, it's going to be false. So this is the only condition that we will have. If I go to the design of the table, because that's the only way I could color the background of the cells through that feature. We're talking about and is it clear that both of them must be true? On the other hand, or at least one of them must be true, or must be true in order for the whole thing to be true. In order for the whole thing to be true. So this way, when we talk about and, if I do look at those 2 sets here, and I'm not going to really get into mathematics as much as the concept of it. If you take a look at A or B, this is going to result into the elements in both sets. So even as you notice, 1 belongs to the first one, so it has to be mentioned. 2 is in both sets, we mention it one time. 3 in both sets, we mention it only one time. 5 in the first set, we must mention it. 7 and 8. You notice it's so inclusive result that included everything from both sets, which is very easy, understandable, and that OR is an inclusive operator. So if I ended up with trying to avoid inventing the wheel here, I'm going to go ahead and steal this table from here by copying it and pasting it in order to find the OR, truth table for OR. I could go ahead and replace only this part in with OR, replace it, and don't go any farther with the replacement. Only this is what I want. So true and true, since both are true, and I need at least one of them to be true for the whole thing to be true. So this is true. True or false is going to be true. And false or true is going to be true, because I need one true to be the whole thing, for the whole thing to be true. False or false, obviously this is the only time we're going to get it actually as a false. So this one, I could actually indicate this by a red color to eliminate those. Will continue to be green or yellow, whatever your favorite color, and to indicate the success of getting true. Of course, I'm not going to, I'm going to the design here to go ahead and change it to, say, greenish for everything to be green. Okay, so that's fine with me. Green is a better color for success, and here we could leave it in. So also, if you want to just change it to green, that's fine. When it comes to XOR, XOR is an exclusive OR. It tells me, look, you have 2 people that you send to the conference in order to hold it. That's too much resources. The conference only need one and only one of the 2 people that you mentioned earlier that they should show up in order for the conference. If 2 of them showed up, that's no. And if none of them showed up, that's also no. So what are we going to see here as a result? That if both conditions are true, it's going to give me a false with the XOR. If both of them are absent, of course, it's going to give me false. So the only time I'm going to get a true if I have one of the condition to be true. So I'm going to go ahead and copy this as I did before, not to reinvent the wheel. And you'll notice here, since at least one of them has to be true for the whole thing to be true. Otherwise, no matter what, it's going to be false. So notice here, this false, let's go ahead and change it to XOR. I'm going to replace it with XOR, replace OR with XOR, and only replace this area here. No additional and additional here. Uh-oh, I keep replacing it. All right, let's go ahead and see if we can actually do undo. So, all right, let's go ahead and close. All right, too many X's here. I'm going to take 3 of those. Take 3 X's here, and take this 3 X's here. I was terrified by the fact that it's going to change every OR above. Anyway, this is basically, it's going to go ahead and change. Let's go to the design and change this to the red. So because the only time we're going to get a true, we only have one true for both of them. All right, the not is a different type of animal because not actually it's a negation type of operator. So it's very easy to relate to it because if not false, it's going to give me true, and if it's not true, it's going to be false. So this is basically clear to me that it's not, as most people confuse it. Whatever you have in front of the not is going to give you the other side of it. So it's a Boolean value. If it's not false, it's going to be true. If it's not true, it's going to be false. So this is a unary operator, meaning it works in one condition. The condition, however, it could be very complicated, which could include hundreds and maybe tens or whatever, ors and it could be very complicated. I'm exaggerating here, but the point is clear that if I say here, for example, not if I say here 9 not equal to 3, that is true. Let's say here, or I say here 3 less than, let's say, 10, which is a true. So true or true is a true. The result from the whole thing is going to be false because not true is false. So not is a very powerful operator that takes whatever from it and give you the other. Also, if I say here not accounting in a business administration department, and if I say here not accounting, that means any other department except accounting. So should cover the logical operator one more time, just to refresh your memory. And I hope you will continue watching what's coming up because we're going to discuss the different type of coding systems that are available for us. Thank you for watching. Hopefully I will see you in the next video in a few seconds. Bye-bye.